Alright, this is Notes 56. So today our goal is going to be to learn how to find the missing angle of a right triangle using trig ratios. So before we do that, I do want to spend a little bit of time here reviewing how to find the missing side length using trig ratios. So example A. So in this triangle here, if I want to find side BC, notice how I'm going to first come to my triangle and I'm going to mark that side BC as my x. So I'm looking for x here. So with having this side marked as x, now the first thing that I'm going to do is I'm going to choose a reference angle. So I'm going to choose an acute angle. So I'm going to choose an acute angle on my triangle to work from. So we have to first choose an angle to work off of to be able to label our sides as opposite and adjacent. So in this case, because this angle A is already given to me, I'm going to choose angle A. So I'm going to go ahead and choose angle A as my reference angle here. Again, I'm going to draw a little stick figure on angle A just as a reminder to myself. That's my reference angle. Once I have chosen an angle to work from, then next I will identify the hypotenuse. So your next step here is to identify the hypotenuse of your right triangle, which is always across the right angle. So the hypotenuse is always the longest side, and it's always across the right angle. So in this case, here's my right angle. So my hypotenuse is going to be the side AC. And so I'm going to label that with an H for hypotenuse. Next, I will then identify the opposite side and the adjacent side, which are relative to the angle that I've chosen to work from. So I'm going to then identify the opposite side, so the opposite side, and the adjacent side, again, relative to the angle that we've chosen. So to identify these, if we've identified angle A as our angle for this triangle, then the side opposite of angle A is going to be side BC. So this is my opposite side to angle A. My adjacent side to angle A is going to be side AB here. So I'll put this as an A. Once we identified all of our sides relative to our angle here, next we're going to use SOHCAHTOA. So we're going to use SOHCAHTOA to help us decide which trig ratio we want to use. So in this case, the way that I do that is if I look at my triangle, notice how I'm looking for this side here. So I'm going to call that x. So I'm going to use this side. This adjacent side has a length of 15, so I can use this one. Notice how in this case the hypotenuse has no value here. I don't know how long this side is. I'm not looking for it in this question. So in this case, I don't need to use the hypotenuse. So I'm going to kind of ignore that side. By doing that, notice how I am going to use the O and the A. So if I look at SOHCAHTOA, I want to find which of my three trig ratios uses the opposite side and the adjacent side. So where do you see an O and an A in these three? And if you look carefully, there's an O and an A right there, which tells me that I'm going to use here tangent. So I'm going to choose to use tangent in this question based on the sides that I'm going to use to set up my fraction. So with that, I'm going to choose to use tangent here. And so now I can set up an equation that looks like this. Tangent of the angle that I've chosen equals opposite over adjacent. So it's like this. Tangent of 30 degrees, the angles that we chose, equals opposite. Remember that opposite here is x over the adjacent side, which is 15, which goes here. And so we've now created an equation that we can solve for our missing side. In this case, to solve this equation, I'm going to multiply both sides by 15. So then these 15s cancel. And here I get x equals 2. Remember that at this point, this is now the job of the calculator. So you're going to type in 15 times tangent of 30. And if you do that, you end up getting 8.66. So if I go to my nearest hundredth, that is the length of side BC, which is right here. Okay, example B. A ladder needs to reach the second story window, which is 10 feet above the ground and makes an angle with the ground of 70 degrees. How far out from the building does the base of the ladder need to be positioned? So here's kind of an image of the situation. So first, let's kind of put this information onto the picture. So the ladder needs to reach the second story window, which is 10 feet above the ground. So I'll start with that. So this ladder here is 10 feet above the ground. So this is going to be 10 feet above the ground. Next, it makes an angle with the ground of 70 degrees. So what that means is that this ladder here makes an angle that's 70 degrees. So this is an angle of 70 degrees here. This will be a right angle here at this point, because it's going to be, the wall should be straight up and down with the ground. And then it asks you, how far out from the building does the ladder have to be positioned? So in this case, I want to find out how far is this ladder away from the building. So what is this side length? So I'll put this in blue so you can see it better. I'm looking for this side length. So if you look at this picture, if I complete it, notice how this is just a right triangle that has an angle of 70 degrees here, a right angle there, and then a side length of 10 and 1 of x. So if I redraw this triangle kind of here on the side, so it's a little bit easier to see, I have this triangle. You can see I'm just copying it from the building itself. So I'm now looking at this, I want to solve for this side of x. So in this case, my first step is now going to be to pick a reference angle. So I'm going to pick this 70 degrees. So if I'm standing at this angle here, next my hypotenuse is going to be this blank side. So this is my hypotenuse. The side opposite this angle 7 that I've chosen is going to be the 10. So this side is opposite this angle that I've chosen. So this is my opposite side. And this makes this my adjacent side. Once I've done that, notice how in this example again, I'm looking for this side, which is x. I know this side is 10, but do you see how in this case the hypotenuse has no value for me? So I really can't use it, so I'm not going to use the hypotenuse here. So once I identify what I have to use, here's where I now think about SOHCAHTOA. So if I write SOHCAHTOA again, here's where I can decide which trig ratio am I going to use depending on what I have to use on my picture. So I'm going to use O and A. Well, O and A is going to be here. So because I see O and A there, I'm going to use tangent. So now I can set up my equation. Tangent of the angle that I've chosen, which is 70 degrees, equals to opposite, which is 10, over adjacent, which is my x. And so now I have my equation. At this point, hopefully you can see that this is just a proportion. So I can solve using cross product. So then I get x times tangent of 70 equals 1 times 10 is just 10. And to solve this equation, I can divide by tangent of 70 to both sides. So divide tangent of 70 to both sides. So this cancels here on the left, and I end up with x equals 2. And again, at this part of the problem, this is the job of the calculator. So you're going to press 10 divided by tangent of 70, and you'll get that it's going to be approximately 3.64 feet. So today's focus now is going to be, how do we use trig ratios to find missing angles of a triangle and not just missing sides? So first, guys, again, we're going to have to use a calculator. So down here below, I've given you guys a picture of a calculator in my classroom. Also my iPhone calculator. But if you wanted to use one online, Desmos.com/scientific is a great tool to use as well to do these computations. So, guys, to find a missing angle using trig ratios, we have to use the inverse trig ratios. So an inverse trig ratio is used to find an angle measure when you know two side lengths. So we need to have two side lengths for this to work. And this looks like structurally, it's going to look like this. So a trig ratio, so either sine, cosine, or tangent, with a little negative one on top, the fraction or ratio that's going to equal to the angle measure. So for example, in this case, if I saw this here in one of my questions or assignments, this reads as inverse sine, so inverse sine of 3/5 equals to angle A. So this is the inverse trig ratio. The little negative one denotes it's the inverse of sine. This is our ratio or fraction, and it equals to an angle measure. Guys, a quick note, the notation here to represent inverse trig ratios denotes an angle measure in degrees. So the negative 1 that you see here is not an exponent. Okay, so at this point now, let's try to actually calculate some missing angle measures by using inverse trig ratios. Example C. In this case, I'm looking to find what is the measure of angle B. Notice how here I don't know this angle here, so I'm looking for angle B. So with that, what I'm going to do is I'm trying to solve this equation to get angle B by itself. So I need to undo this tangent. And so to undo the tangent, I'm going to use the inverse of tangent. So I'm going to multiply both sides by inverse tangent, which is that guy. But I'll do it to both sides. So I have to put this on both sides. I could do it with any equation. At that moment then, the inverse of tangent and tangent are going to be opposites, so they're going to cancel. So this gets rid of tangent. And what comes out here is angle B. So the measure of angle B equals to inverse tangent of 36/19. Again, it's the inverse trig ratio and some actual ratio here, some fraction. So at this point now, this is now again the job of the calculator. But to use this, or to get this to work on a calculator, here's how it works. On a calculator itself, like this one here in my classroom, if you look at the actual sine, cosine, and tangent buttons, right above them on the actual calculator casing, you'll see here, let me zoom in. You're going to see here the little inverse of sine, inverse of cosine, and inverse of tangent. To activate these inverses, you have to press the shift button first, then press whichever one you want, and it'll activate for you the inverse trig ratio. That's on this calculator. Now on my iPhone, if I want to get an inverse trig ratio, see in my current iPhone I see sine, cosine, and tangent. So I don't see it here. So what I'll do here is I'm going to press this second button. When you press the second button, it'll change these sine, cosine, and tangent. It'll change these to now inverse sine, inverse cosine, inverse tangent. So when the second button is pressed, it gives you the inverses of your trig ratios. So using that, you're going to go ahead and press now inverse or second tangent, 36/19, and if you press equals at that point, you're going to get here that the measure of angle B is equal to approximately 62 degrees. Again, the key here is that this is going to be calculator work once you solve for angle B. Alright, so with that being said, here's example D. So I want to solve in this case for angle P. So my job here is to move this cosine to the other side. So I'm going to multiply using the inverse of cosine. So inverse of cosine to both sides. So inverse cosine to both sides. So this cancels cosine. Here the measure of angle P, so angle P comes out free and clear. Then I have to compute on a calculator the inverse of cosine of 7/13. Again, at this point on a calculator, if I just put all this into a calculator, I'll get, in this case, the measure of angle P equals to approximately 57 degrees. Because again, we have to practice using our tools, either our iPhone calculator or our phone calculator, an actual calculator, or just using the Desmos calculator to compute the angle measures. Example E. Here I want to solve for angle A, so my job is to move this sine to the other side, so I'm going to use the inverse of sine. So the inverse of sine to both sides, because on the left-hand side, sine and inverse of sine cancel, so the measure of angle A comes out free and clear, and I get inverse sine of 1/2. So again, at this point with a calculator, if you just press those buttons, you find that the measure of angle A here equals to about 30 degrees. Okay, next, so for examples F, G, and H, we want to find the measure of the specified angle and then round to the nearest degree. So example F, I want to find the measure of angle L. So I'm looking for this angle here, angle L. So I'm going to go ahead and call this, well, I'll leave it as angle L for now. So in this case, I'm going to choose first an angle to work off of, and because I'm using angle L, I'll just choose that. So I'm going to choose this as angle, my reference angle. So again, my little stick figure there. I'm going to identify my side, so my hypotenuse is going to be 18. Then from angle L, the side opposite angle L is going to be 11. This is my opposite side. And then the adjacent side is going to be this one there. At this point, using SOHCAHTOA, notice how in this case, the hypotenuse is 18, the opposite side is 11, but I don't know my adjacent side, so I'm not going to use the adjacent side. So thinking about SOHCAHTOA, I'll write it down so you can see it again. In this case, I'm going to use opposite and hypotenuse. So if you scan all three of these, the only one that has opposite and hypotenuse is going to be sine. So because of this, I'm going to use sine here to create my equation. So I'm going to write now sine of angle L, which is the angle that I chose, equals to opposite, which is 11, over hypotenuse. And so now I've created an equation where I can find or solve for the measure of angle L. So here I need to cancel the sine, so I'm going to use the inverse of sine to both sides. Inverse of sine and sine cancel. The measure of angle L is an isolated, and I'm left with inverse sine of 11 over 18. And then with a calculator at this point, if I just press those buttons, I'll find that the measure of angle L is about 38 degrees. So it's about 38 degrees. Now with that being said, I found this angle to be 38 degrees. Guys, to bring back one of our triangle truths, remember that we know that for any triangle, if we add all three angles, they must make 180. So in a right triangle, since one angle is already 90, the other two angles have to be 90 as well, because 90 plus 90 is my 180. So in this case, once I find angle L, I can then pretty easily find the measure of angle J, because angle L and angle J have to add to 90. So here, really quickly on the side, 90 minus 38 will give me 52, and just like that, I can find my other angle in this right triangle. Remember, these must add to 90 in a right triangle. Okay, example G. Find the measure of angle S. So I'm going to go ahead and choose angle S as my reference angle here. So I'll label this angle. There's my famous little stick figure. Then next I'll identify my side as hypotenuse. The side opposite angle S is going to be 15. And the side adjacent to angle S is going to be 12. Okay, at this point, using SOHCAHTOA, I'm going to decide which trig ratio to use based on what I have in my triangle. So in this case, notice how adjacent is 12, opposite is 15, but my hypotenuse has no value. So I'm not going to use the hypotenuse here. So because I'm going to use opposite and adjacent, that's going to be my tangent trig ratio. So I'm going to use tangent in this case. So now I can set up my problem. So tangent of angle S is going to equal to opposite, which is 15, over adjacent. So again, I've created an equation I can solve for angle S. So in this case, if I'm going to solve for angle S, now what I can do is I can multiply both sides by the inverse of tangent, so that the inverse of tangent cancels with tangent. Then the measure of angle S will come out isolated. And then at this point, all you have to do is use your calculator and type in inverse tangent of 15 over 12. And if I do that here with the calculator, then I end up getting the angle S is approximately 51 degrees. Remember that if you find this angle to be 51 degrees, then you can pretty quickly find the other angle here, because these two have to add to 90, so this will be 39 degrees. Just kind of doing that in my head, because these two have to make 90. Because remember, in any triangle, all three angles have to make 180, but in a right triangle in specific, one angle is already 90, so 90 plus 90 will make 180. Example H. Here I want to find the measure of angle y, so I'm going to mark y as my angle. So now I'm going to identify my hypotenuse, my side opposite, and side adjacent. Again, using SOHCAHTOA. In this case, notice how my opposite side has no value there, no length, so I'm not going to use that one. So because I'm going to use here adjacent and hypotenuse, that's going to tell me to use cosine. So that's how I can tell which trig ratio to use depending on the question. So I'm going to use cosine. So I can write cosine of angle y equals to adjacent over hypotenuse. Now to solve the equation for angle y, I can use inverse cosine on both sides to cancel cosine. So here angle y is isolated, equals to inverse cosine of 14 over 23. And with a calculator, I can find that the measure of angle y is equal to 53 degrees. And once I find this to be 53 degrees, I know that these two have to make 90, so then angle z is going to be equal to 37 degrees. So it's pretty easy to find the third missing angle in a triangle once you know 2. Okay, example I. So in this case, we're going to try to put everything all together. So here I want to find the missing sides and the missing angles in this case. So first, I'm going to go ahead and pick a reference angle to start with. So I'm going to pick angle A, since I already know it. So I'm going to kind of label my hypotenuse, my opposite side, and my adjacent side. Next, I'm going to try to find angle B, because that should be easier. If this is already 90, and then this is 32, then angle B here has to equal to 58 degrees. Because, again, think about in any triangle, all three angles have to add to 180. So in a right triangle, if this right angle is already 90, these two acute angles must add to 90. So 32 plus 58 gives me my 90 degrees. So I can do that one kind of almost in my head. Part B, I want to find AB. So if I'm going to find AB, then in that case, I'm going to call AB, well, I'll leave it as AB. So I'm going to just call this AB here. So if I'm looking for this side AB, and I know that this side is 10, I'm going to use adjacent and hypotenuse. So if you think about SOHCAHTOA, I'm going to use AH here, so I'm going to use cosine. So I'm going to pick to use cosine to find my side of AB. So here I go, cosine of 32 degrees, which is the angle that I chose here, is equal to, is equal to adjacent over hypotenuse, which is my unknown AB. Next, because this is now a proportion, I can cross product, so I end up getting AB cosine of 32 equals 1 times 10 is 10. I can divide both sides by cosine of 32. And so then I get AB, which is my missing side, equals to, because at this point this is all going to be on the calculator. So if I put 10 divided by cosine of 32, I get that AB is about 11.8 units long. So that's 11.8. To then find BC, I'm going to use my same setup, but again, think about, in this case, to find BC, I'm going to use here adjacent and opposite. So I'm going to use those two. So to use adjacent and opposite, that's going to be TOA, that's tangent, so I'm going to write tangent of 32 degrees. Again, I have not changed my angle here. Equals opposite, which is BC, my unknown side here, over adjacent, which is 10. I'll times both sides by 10. So in here, I'm going to just type in 10 times tangent of 32. And if I do that, I can compute that BC is going to be approximately 6.2 units. So we can go about and find any right triangle. We can find all of its missing sides and angles by one at a time using our trig ratios or our triangle truths to find those missing values. Alright, so class trig 56, here's number 1. We want to find x round to the nearest degree. So in this case, I'm going to first pick a reference angle, which will be this one, and then identify my sides as hypotenuse, opposite to my reference angle, and adjacent. So once I do that, notice how in this case my hypotenuse side has no value, so I'm not going to use this in this case. So I'm going to use opposite and adjacent. So in my SOHCAHTOA, OA is going to be tangent. And that's how I'm going to pick which one to use. I can write tangent of my missing angle x equals to opposite, which is 3, over adjacent, which is 10. Then I can solve for my missing angle x by using the inverse of tangent to both sides. So this inverse cancels tangent, so then I end up getting that x equals to inverse tangent of 3 over 10. With the calculator, if I type this in, I find that my missing angle is approximately 17 degrees. So that's how we use our inverse tangent or inverse trig ratios to find a missing angle. Number 2, here I want to find this angle x. So again, first identify my reference angle. So I can then identify my sides as hypotenuse, opposite my angle, and adjacent to my angle that I've chosen. So in this case, notice how I'm not going to use the adjacent side because there's no value for me to use there. So if I don't use this one, I'm using O and H. O and H in SOHCAHTOA is sine. So I'm going to use sine here. So I'm going to say sine of my unknown angle x equals to opposite over hypotenuse. And to solve for this angle x that I don't know yet, I'm going to use inverse sine on both sides to cancel sine here on the left. So I get x equals to the inverse sine of 9 over 10. And so that's an inverse sine. So then at this point now on a calculator, if I just press that, I find that my missing angle is approximately 64 degrees. Number 3, here I'm missing this angle x. So again, first picking a reference angle. My hypotenuse is 12. My side opposite my angle is this blank side, and my adjacent side is 11. In this case, notice how my opposite side has no value for me to use, so I won't use the opposite side. So I'm going to use the adjacent and hypotenuse. That's AH, that's going to be cosine. So I'm going to use cosine here, so cosine of my angle x equals to adjacent over hypotenuse. In this case, I'm going to use the inverse of cosine to isolate x by itself, so inverse cancels cosine. So x equals to the inverse of cosine of 11 over 12. And again, on the calculator, if I press that, I find that this missing angle is approximately 24 degrees. Okay, number 4. Now in this case, you have a little bit of a word problem, so you're going to want to draw a picture of what it's saying to then understand what's going on. So it says, Jed is building a roof for his shed. The highest point of the roof will be 3 feet higher than the top of the shed. So at this point, let me first draw that. So here's a shed. And he's going to add a roof to it, something like this. And what it's saying is that the highest point of the roof will be 3 feet higher than the top of the shed. So this highest point here is 3 feet higher than the top of the shed. So this is going to be 3 feet higher here. Then it says the slanted roof will be 7 feet long. So this slanted roof here is 7 feet long. What is the measure of the angle formed by the top of the shed and the slanted roof? So what is the angle formed by the top of the shed and the slanted roof? So I'm going to find out what is this angle here. So all of a sudden I can look at this picture as a right triangle. So if I just focus in on this little right triangle here with a side of 3, a side of 7, and this missing angle x, and I redraw it just here on its own for clarity, so I just redraw the triangle by itself, where I have this angle x, side of 7, and a side of 3. Then I can use my trig ratios to find this missing angle. So at this point, again, picking my reference angle, here's my hypotenuse, my side opposite, and my side adjacent. In this case, I'm not going to use my adjacent side. So using now SOHCAHTOA, notice how I'm going to use A and H. So that's going to call on cosine in this example. So I'm going to choose cosine. So I'm going to write cosine of my unknown angle x equals to the adjacent side. Guys, sorry, I chose the wrong one. Let me try that again. So again, I'm sorry guys, I made a mistake there. In this case, I know the opposite side is 3 and the hypotenuse is 7, so I'm not going to use the A here. So I'm not going to use the A, so I'm going to use the opposite side and the hypotenuse. So I'm going to find that in sine. That's where I get opposite hypotenuse. So I'm going to use sine in this example. Sorry about that error. So I'm going to say sine of the angle that I don't know, x, equals to the opposite over the hypotenuse. And now I can solve my equation for this unknown angle x by multiplying both sides by the inverse of sine to cancel this sine out. And so I get x equals to the inverse of sine of 3 over 7. So on a calculator, I can compute then that this angle here is going to be approximately 25 degrees. Okay, number 5. So again, this is another word problem with no picture, so I'm going to draw a picture. The ramp on the back of a moving van is 2.5 feet high and rises at an angle of 18 degrees. How long is the ramp? So first, let's draw a moving van. So here's a quick little moving van, and it has a ramp that comes down off of the back, something like that. And so notice how, if I think about the ramp, there's a triangle there that I can see. So it says that the ramp is 2.5 feet high. So this ramp is 2.5 feet high. So it's 2.5 feet off of the ground. And it also says that it rises at an angle of 18 degrees. So this angle here of elevation is 18 degrees. What I want to find is how long is the ramp. I want to find out how long is this ramp. So I'm going to find this missing side. If I redraw this triangle here for more clarity, so again, just draw a right triangle, have an angle of 18 degrees, a right angle there, a side of 2.5, and I'm looking for this side there. That's the same thing, but now I'm just taking the story out of it and just looking at a triangle. So now I can solve using my trig ratios. So here, again, I'm going to first pick my reference angle, and from here, I have my hypotenuse, my opposite side, and my adjacent side. In this case, notice how my adjacent side has no value for me, so I'm not going to use this adjacent side. So using SOHCAHTOA, I'm I'm going to be using the opposite and hypotenuse. So the opposite and hypotenuse, that is going to be sine. So I can say sine of 18 degrees equals opposite over hypotenuse. And here, this is a proportion, so I can use cross product. So I get x sine of 18 equals 1 times 2.5 is 2.5. I can then divide sine of 18 to both sides. And on a calculator, too many equal signs there, sorry guys. On a calculator, 2.5 divided by sine of 18 is 8 feet. So I can find that the length of this ramp is 8 feet long. Alright, and lastly guys, number 6. This is a challenge question. So in this case, notice how we have this kind of funky image or figure, but if I look at it carefully, I do see here two different right triangles. So I'm going to first redraw. I'm going to redraw this original picture, but I'm going to separate my two triangles. So in this case, before I redraw them, I will first find this shared side, this missing W value. So let me first focus on just this. I'll call this the red triangle. So I'm going to first focus on this red triangle. And if I choose this as my reference angle, I have my hypotenuse, my opposite side, and my adjacent side. So in this example, using SOHCAHTOA, notice how in this case, to find this missing side of W, I'm going to use my hypotenuse and my opposite side. That's going to be sine. It's OH. That's going to be OH. So using sine, I can say sine of my angle of 44 degrees equals opposite over hypotenuse. And here I can solve this equation for W. And on a calculator, if I type in 30 times sine of 44 degrees, I find that W is approximately 20.8 units long. This is 20.8. Now what I can do is redraw this second triangle, which I'll call my orange triangle. So I draw this triangle here on its own. I know that this side here is now 20.8. I know that this side is 45, and I now have this missing angle. So to find this missing angle, I'm going to use my inverse trig ratios here. So again, I'm picking my reference angle. Then I have my hypotenuse, my opposite side, and my adjacent side. And here, I know my hypotenuse and my adjacent side. So using SOHCAHTOA, that's going to be, in SOHCAHTOA, that's going to be, AH is going to be cosine. If you see it here, it's cosine. So I can say cosine of my unknown angle is equal to the adjacent side divided by the hypotenuse. And I can multiply both sides by the inverse of cosine to cancel the cosine out there. And I get x. Guys, on a calculator, if I can type in inverse cosine of 20.8 over 45. Sorry, that's meant to be a 20. I wrote that kind of sloppy. So 20.8. On a calculator, I can find that the angle is approximately 62 degrees. So guys, a lot of this work here is going to be heavy and dependent on using a calculator to compute your final answers.